Hi, in this video, I will be discussing what is a regression analysis and how to do it. Regression analysis is a conceptually simple method for investigating functional relationships among variables. This will be a series of videos discussing simple and multiple linear regression. Regression analysis is a set of statistical methods used for the estimation of relationships between a dependent variable and one or more independent variables. It can be utilized to assess strength of the relationship between variables and for modeling the future relationships between them. Regression analysis includes several variations such as linear, multiple linear, and nonlinear. The most common models are the simple and multiple linear regression. Regression analysis includes the following steps: stating the problem, selection of potentially relevant variables, data collection, model specification, choice of fitting method and model fitting, model validation and criticism, and using the chosen model. Let's first discuss the first step, stating the problem. Regression analysis usually starts with a formulation of the problem. This includes the determination of the questions to be addressed by the analysis. The problem statement is the first and perhaps the most important step in regression analysis. It is important because an ill-defined problem or a misformulated question can lead to wasted effort. It can lead to the selection of irrelevant set of variables or to a wrong choice of the statistical method of analysis. A question that is not carefully formulated can also lead to the wrong choice of a model. Next is a selection of potentially relevant variables. This step requires the researcher to select a set of variables that are thought by the experts in the area of study to explain or predict the response or dependent variable by reviewing related literatures and studies. The response variable or the dependent variable is denoted by Y, and the explanatory, predictor, or independent variables are denoted by X sub 1, X sub 2, and so on. The third step is data collection. In this process, the researcher collects the data from the environment under study to be used in the analysis. Sometimes, the data are collected in a controlled setting so that factors that are not of primary interest can be held constant. More often, however, the data are collected under non-experimental conditions where very little can be controlled by the researcher. In either case, the collected data consists of measurements for each of the potentially relevant variables. The fourth step is model specification. The form of the model that is thought to relate the response variable to the set of predictor variables can be specified initially by the experts in the area of study, based on their knowledge or their objective or subjective judgments. The hypothesized model can then be either confirmed or refuted by the analysis of the collected data. Note that the model needs to be specified only in form, but it can still depend on unknown parameters. A regression equation containing only one predictor variable is called a simple regression equation. An equation containing more than one predictor variable is called multiple regression equation. The fifth step is method of fitting and model fitting. After the model has been defined and the data have been collected, the next task is to estimate the parameters of the model based on the collected data. This is also referred to as parameter estimation or model fitting. The most used method of estimation is called the least squares method. Under certain assumptions, least squares method produces estimators with desirable properties. Other method includes maximum likelihood method, the ridge method, and the principal components method. However, we will be using the least squares method. Also, for our demonstration, we will be focusing much on this process. The estimates of the regression parameters beta sub 0, beta sub 1, and so on are denoted by beta hat sub 0, beta hat sub 1, and so on. A hat on top of a parameter denotes an estimate of that parameter. The sixth step is model criticism and selection. The validity of a statistical method, such as regression analysis, depends on certain assumptions. Assumptions are usually made about the data and the model. The accuracy of the analysis and the conclusions derived from an analysis depends crucially on the validity of these assumptions. Before using regression equations for any purpose, we first need to determine whether the specified assumptions hold. We need to address the following questions. What are the required assumptions? For each of the assumptions, how do we determine whether or not the assumptions is valid? And what can be done in cases where one or more of the assumptions does not hold? The standard regression assumptions will be discussed in another video. The last step is to use the chosen model for the solution of the posed problem. The explicit determination of the regression equation is the most important product of the analysis. It is a summary of the relationship between the response variable and the set of predictor variables. The equation may be used for several purposes. It may be used to evaluate the importance of individual predictors, to analyze the effects of policy that involves changing values of the predictor variables, or to forecast values of the response variables for a given set of predictors. Although the regression equation is the final product, there are many important byproducts. We view regression analysis as a set of data analytic techniques that are used to help understand the interrelationships among variables in a certain environment. The task of regression analysis is to learn as much as possible about the environment reflected by the data. We emphasize that what is uncovered along the way to the formulation of the equation may often be as valuable and informative as the final question. That's it for our video. Thank you very much for watching and have a great day.